Whoa, welcome guys. So today let's solve this interesting question. So this interesting question will give you an amazing technique that you may not think or you may not learn when you're in high school. So let's suppose you have a polynomial, degree is n, and which satisfies a strange rule that p of k is k divided by k plus 1. Okay, and the k is from 0, 1 to 2 to n, and you need to find p n plus 1. So before I start, please leave a comment and subscribe my channel and click that button. Okay, so remember that in the previous question, we have a previous question. I will leave the link below. Basically, we solve some interesting polynomial satisfy these two rules. So what I say powerful technique is that if you have a polynomial with degree n, and you already have n plus 1 points, which they are all different, and they satisfy when they plug into the polynomial, you get a constant c. Then it's guaranteed that you can just safely say p of x is c, and the reason is due to the fundamental theory of algebra. Okay. Okay. By the way, if you want to see the proof of fundamental theory of algebra, then I also leave the video below. You need to learn about the complex analysis if you want to prove this thing. Okay. So the idea is that how to find this, right? So this is different from when you learn in high school, right? I mean, if you specific fixed n, let's say if you say n is 2, right? Then you can say p of 0 is 0, and p of 1 is 1 divided by 2, and the p of 2 is just case 2, right? And then you can solve p of x, and then you plug p of 3, right? But we don't want to do this, right? If we do this, then it's hard to guarantee that what we will get, right? Because we need to find the rules, right? So the idea is that we cannot just solve this. So if you use this idea that basically you are assuming that p of x is x squared plus bx plus c, and then use this 3 to get the abc, and then you plug p of 3, right? This is the general rule. But I don't want to do this. So I want to give the powerful, use the powerful reason, powerful idea, as we say. So ideal is that I can define, let's do it step by step. So I can define q of x, right, to be x plus 1, p of x minus x. Right? I think everybody sees the trick. So how about q of k? So q of k will be k plus 1, p of k minus k, right? And that is 0. So this tells me that q of x has k equals 0, 1, 2, up to n. They are all n plus 1 are roots. Okay, so and notice that p of k is degree n, right? So this q is at most what? At most n plus 1 degree, right? So but you already have n plus 1 roots, right? So that means I can write q of x as some constant a times x, x minus 1, x minus 2, up to x minus n, right? So now I can get I can safely and by the way, this is a p of x, x plus 1, p of x minus x. So I can safely say that p of x is just x plus a x minus x minus 1, x minus n divided by x plus 1, right? Or basically you don't have to write this, you just write as this. Okay, so the idea is that how to find a, right? So it's very easy. I don't know what you guys think, but you can plug x equals to minus 1, right? So very easy. So x equals to minus 1. And the right hand side, left hand side, you get 1, right? And the right hand side, you get a minus 1 minus 2 minus n, right? So this is a times n factorial and the minus 1, I think. Okay. Let's see. So if you plug x equals to n plus 1, sorry, you get n plus 1 and n, right? So there should be n plus 1. And so this n plus 1 and sorry, you get x equals to minus 1, right? So the final term is minus 1 minus n, right? So you get a times minus 1 to n plus 1, n plus 1 factorial. Okay, so you get your a to be minus 1 to the n plus 1. Just divide it and the n plus 1 factorial. Okay. Okay, so now we can get our p of x from this, right? So we get let's write down. Your p of x will be q of x plus x divided by x plus 1. So right, will be minus 1 n plus 1 divided by n plus 1 factorial x minus 1 x minus 2 up to x minus n plus x divided by x plus 1. Right, so you get p of x. Now it's very stupid. You just plug px equals to n plus 1. Okay, so x equals to n plus 1. You get what? You get this term, right? So these two terms cancel. So you get minus n plus 1 plus n plus 1, right? And n plus 2. Right, so you can see that if, let's say, if n is odd, right? N is odd, then this term, minus 1 to n plus 1 will be 1. So it's n plus 1 divided by n plus 1, which is 1. If n is even, then this term will be minus 1. So you get n divided by n plus 2. Okay, now you can check for the stupid exercise. If you do exactly use the same way to prove for n equals to 2 case, then you should right, you should get the p of 3 to be 2 divided by 4, so it's half. Okay, so just interesting question. So this right, so now if you see technique, so if you change this p of k to k squared or something others, then you can still use this type of way to solve it. If there are these are a strange function at f of k, right, and you can change it and try to build this q of x and use the same idea to find a non-trivial constant, and hope this idea will give you to solve the original p of x. Okay, so this is my video. Hope you guys subscribe to my channel. See you next time.